The topic of my presentation is technical yarn. First, we will look at the definition of technical yarn. Yarn is a linear assembly of textile fibers or filaments formed into a continuous strand. If we look at the groups, it can be subdivided into three groups. First, the continuous filament yarn. This has, I think, 90% share of the total technical yarn fabric. The second is the spun yarn, and the third is the plied yarn. Looking at the groups of the spun yarn, we can have ring yarns, rotary yarns, friction yarns, air jet yarns, or twistless yarns. The ring yarns have further three groups: the carded, the combed, and now the compact and the co-spun yarn. Here is the layout of the spinning process, which is used to produce the ring spun yarn. You can see from the cotton bale, we first feed this material into the blow room, and then from the blow room, the next process is the carding. From the carding, it comes into the drying. From drying, it has two lines of production. If we want to produce a combed yarn, we will have to take it to the comber, or if we want to produce a carded yarn, we directly take the material to the roving process, from where it is directly spun. In case of combed yarn, we first make the comber lap, then it goes to the combing machine, and next is the drying process, and again the roving and the spinning. Here is the image of the ring spinning machine. You can see there is a small, the package size is very small in this case, but the quality of the yarn produced is even better than all other type of yarn. Here is an image of the compact yarn. The compact yarn is a ring spun yarn, with only the difference that the fibers are better aligned. You can see that only there are a few protruding fibers. The benefit of the compacting process is that we can get higher material utilization, higher tenacity with the same twist factor, or identical tenacity with reduced twist factor for higher productivity, lower hairiness, and improved yarn irregularity, fewer weak places in the yarn, improved yarn imperfections, higher abrasion resistance. This is the image of the rotor spinning machine. In the rotor spinning process, we have a combing roller. Here is the feed material. This combing or opening roller opens the material and throws the material into the groove of the rotor. The rotor is rotating. This rotation gives the centrifugal force, which accumulates the material in the rotor groove and twists it as well and makes it into yarn. Next. Here's the image of the draft spinning machine. The draft spinning machine is a machine used to produce technical yarns, large number of technical yarns, because in this type of machine, there is a facility to insert even a hard core inside the yarn as steel wires or glass fiber yarns. From this end, the slivers are fed. At one time, you can feed different materials. Say you can feed cotton as well. Along with cotton, you can feed glass fiber, or you can feed some other high performance fiber. The material is first opened. Then there are two rollers. These two rollers have air suction in them, which condense the material on them and then produce a yarn, which is delivered in this direction. Here are some different characteristics of draft spun yarn. Just like as we have higher strength and FR protective clothing for civil and military sectors, fire blockers for aerospace and object sectors, cut resistant textiles, stench fabrics, sun blinds, fiber composites, woven filters for dry and wet filtration, transportation belts, sealing belts, and so on. Here you can see the share of different yarns. You can see the share of ring yarn is very less. Sorry, the share is very high, but the production rate is very low. The production rate of ring is the minimum, and you can see vortex spun or jet spun are the highest. Now we are coming to the next type, which is applied yarns. We have three types of applied yarns: the double yarns, the rat spun yarns, and the elasto twisted yarns. Here is a figure of a 2-for-1 machine that is commonly used for producing plied yarn. This is an image of the elasto twisted yarn. The core is an elastic, and the outer yarn is a hard yarn. So you can get the outer appearance of any quality you require with an elastic property. Here's the machine for the elastic yarn. Here you can see hollow spindle spinning system. In the hollow spindle spinning system, the twist is inserted by a twisting hook, and the main yarn comes from the drafting system, then enters the tube of the hollow spindle, which is twisted on the lower side with a twisting hook, and after twisting, then the yarn is delivered. Thank you.